Welcome, scholars. Let's revise on 1. The periodic table and elements. 2. Reduction-oxidation reaction and electrochemistry. 3. Energy and reactions. 4. Chemical equilibrium. 5. Mole concept and calculations. 6. Organic chemistry and reactions. 7. Separation techniques. 8. Gas laws. 9. Extra points. In the periodic table and elements. State the modern periodic law as, the properties of elements are periodic functions of their atomic numbers. This shows that elements are arranged based on their atomic numbers. The element that's in between metal and nonmetal is a metalloid. Like boron, silicon, selenium, etc. If the electron configuration ends in 3p4, the element is in group 6. If it ends in p2, it is in group 4. In the periodic table, the group number tells you how many valence electrons. The particles inside the nucleus are called nucleons, consisting of protons and neutrons. In reduction, oxidation reaction and electrochemistry. Understand how to balance half-equation reactions, especially in redox processes. Practice identifying the oxidized and reduced species. Ensure you balance both atoms and charges. These skills are essential in this exam. For instance, in this equation, dichromate and hydrogen ion can be balanced in chromium 3 oxide by first removing 3 oxygen from the 7 oxygen atoms. It remains 4. Place 4 before water, making hydrogen atoms to be 8. Then place 8 in the hydrogen ion. The equation by atoms is balanced. Let's balance the charges. Dichromate charge is 2-. Hydrogen ion total charge is 8+. By summation, it yields +6. The product side has no charge. Place 6 electrons at the reactant side so that +6 charge and 6 electrons summed together will be 0. The equation is balanced. Try this one. In electrochemistry, chemistry meets electricity. You should confidently calculate the electromotive force, E.M.F, of cells using standard electrode potentials. Always remember, E.M.F equals E, cathode, minus E, anode. Remember, zinc metal yields zinc ion electrode potential is the opposite charge of zinc ion to zinc. For instance, if zinc metal to zinc ion is minus 0.4, then zinc ion to zinc will be positive 0.4. Acidified potassium dichromate changes from orange to green when it oxidizes something. Note, chlorine gas is made by electrolyzing brine, which is just salty water. During electrolysis of hydrochloric acid, chlorine gas appears at the anode. Hydrogen gas at the cathode. Sodium and potassium ions both have positive reduction potentials. Despite the fact that iodine is a nonmetal, iodide ion gives away electrons easily, making it a strong reducing agent. We can see that in potassium iodide. In energy, heat, combustion, and reactions. In energy and reactions, factors like temperature and light have an effect on the energy of the particles. Recall in collision theory, reactions are all about effective collisions. Combustion always gives off heat, it's exothermic. You should be able to define the heat of combustion and recognize its energy flow. You might need to draw or interpret energy level diagrams. When change in H is positive, it means the products have more energy than the reactants. Nickel helps hydrogenation by lowering the activation energy, making the reaction faster. An esterification reaction is an endothermic reversible reaction of alkanol with alkanoic acid, in the presence of hot concentrated acids, under the temperature of about 150 degrees Celsius, to form esters and water. In chemical equilibrium. Chemical equilibrium occurs when forward and reverse reactions occur at equal rates. Learn how to prepare saturated solutions and understand dynamic balance, especially when solutes like copper, salts are involved. Le Chatelier's principle may help you understand how systems respond to changes in mole concept and calculations. Always use atomic masses correctly. Practice working backwards to find the mass for a given number of moles. I know you don't understand this statement. You'll also need to calculate molecular masses from molecular formulas, especially for organic compounds. For instance, if the relative molecular mass of ethanol is 12 times 2, plus 1 times 6, plus 16 times 1. All give 24 plus 6 plus 16, which is 46. You can be asked to calculate the mole, or mass. For instance, the mass of 0.2 moles of ethanol is 0.2 times 46, giving us 9.2 grams. Also, the mole of 2.3 grams of ethanol is 2.3 divided by 46 to yield 0.05 moles. Try this with all the compounds in this video. Majorly the organic compounds. A 20 centimeters cube of KOH at 56 grams per dm cube gives you 0.02 moles. This is because the molar concentration of KOH is 56 grams per dm cube is 1 mole. The number of moles is concentration in mole per dm cube times volume in dm cube. So we have 0.02 times 1. If 0.02 moles in 125 centimeters cube, the solubility is 0.16 moles per dm cube. You may ask how. Amount in mole over volume in dm cube. A mole is the chemist's counting unit, 6.022 times 10 raised to the power of 23 particles. Be confident with mole to mass and mole to particle conversions, especially when working with organic molecules and chemical equations. In organic chemistry and reactions, be able to draw and name compounds from their condensed formulas. Identify substituents, count carbon atoms carefully, and learn how to name branched alkanols and halogenated compounds. Look at the following ethanol reactions. Combustion reaction. Substitution reaction with phosphorus 5-chloride or 3-chloride. Oxidation reaction using acidified potassium permanganate. It first yields ethanol. Further oxidation yields ethanoic acid. Esterification reaction. Remember the differences between how ethane and ethene react, especially with halogens. The substitution and addition reaction. Recall that for alkanes, their reactions are only combustion reaction and substitution reaction. Methane is prepared by decarboxylation of sodium ethanoate using soda lime. Know this equation. Alkenes undergoes combustion and addition. You can make ethanol by hydrating ethene. Just add steam to the alkene under high temperature in the presence of tetraoxyphosphate 5. Polymerization by addition, oxidation by addition. Alkyne undergoes combustion, addition, polymerization by addition, oxidation by addition, and substitution reaction for terminal alkyne. Ethyne is prepared from calcium carbide in cold water. Look at these 4 isomers of N-butanol. A is butane 1-ol. It is a chain isomer to B, which is 2-methylpropane 1-ol. The two are primary alcohols. They will oxidize to alkanal, then finally to alkanoic acid. Butane 2-ol is a secondary alcohol. It undergoes oxidation to form butane 2-one. It is a position isomer to butane 1-ol. It is also a chain isomer to 2-methylpropane 2-ol, which is a tertiary alcohol. Note that this is named 2-chloropropane 1-ol. This is because there are 3 carbon-to-carbon longest chains. We say prop. They are all single bonds between carbon-to-carbon chains. We say N. Add the ane to prop to get propane. The OH is at position 1, so we say 1-ol. Add the 1-ol to the propane, we have propane 1-ol. The chlorine, which is chloro, is at position 2, we say 2-chloro. It is a substituent, so we say it first. 2-chloropropane 1-ol. Hope you get that. Propyne has 2 pi bonds. Ethene, an unsaturated hydrocarbon, loves addition reactions. It has 1 pi bond. When ethene is polymerized, it forms polyethene, the common plastic. Let's go over separation techniques. A single spot on a chromatogram shows the colored liquid is either a compound or an element. If different spots appear, it shows the liquid is a mixture. Another way of identifying a mixture is by looking at the boiling and melting point of the substance. If it varies and has a wide range, it is a mixture. Iodine can be separated by sublimation because it turns into gas directly. Activated charcoal for absorbing toxins. Water in Na2CO3 10H2O makes up 62.8% of the compound's mass. Look at this. To decolorize sugar, charcoal, activated carbon, is used. It has the power of absorbing colors. Nicotine, in cigarette smoke, is reduced by adsorption, it sticks to the filter. In gas laws, a drop in volume with increased pressure. That's Boyle's law. Check Charles's laws. Gay-Lussac's law says if the reactants and products are gases, their volumes are in simple whole number ratio. Graham's law says the lighter the gas, the faster it diffuses. If we notice 2 gases diffuse at a rate, then they are of the same molar mass like carbon monoxide and nitrogen gas. Extra points. The 5 d-orbitals in a transition metal atom all have the same energy, they are degenerate. That is because they are multiple orbitals of the same energy level. A red universal indicator means you're dealing with a strong acid. A universal indicator has many colors. Nitrogen 4 oxide, NO2, can form 2 types of acids, that's unique. Yttrioxonitrate 5 acid and dioxonitrate 3 acid. Silver and copper don't react with diluted HCl, no hydrogen gas released. They are lower than hydrogen in the reactivity series. Silver chloride is formed by double decomposition, this is because it is insoluble. Mind you, the correct word should be a precipitation reaction. Any compound that is not ionic, it's a covalent compound. Like nitrogen 4 oxide, sulfur 4 oxide. Apart from potassium and sodium carbonate, other carbonates decompose under heat in our level of study. If more energy is released when bonds form than is used to break them, it's exothermic. Gases of the same molar mass diffuse with the same rate. A green precipitate with NaOH hints that iron 2 ions Fe2+ may be present. If brown, it is iron 3 ions Fe3+. Biotechnology is used in baking, wine, antibiotics, but not in soap making. The empirical formula is the simplest whole number ratio of atoms in a compound. Learn to solve them. Thank you for watching. Remember, chemistry is not magic, but methods.